Look up on a clear night. Every star you see could host a planetary system like ours, many of them older, some far more advanced, with billions of stars in just our galaxy. Life should be everywhere. Civilizations, signals, structures, and yet nothing. No messages, no alien megastructures, no spacecraft. Just a haunting silence that has baffled scientists for decades. This is the Fermi Paradox. And one theory stands out, unsettling, brutal, and possibly true. Something is stopping intelligent life from surviving. This is the Great Filter. In 1950, physicist Enrico Fermi casually asked, "Where is everybody?" Given how old the universe is, over 13.8 billion years, and how many Earth-like planets exist, advanced civilizations should be common. Some should have spread across the stars already, colonizing galaxies. If even a tiny fraction of intelligent species survive long enough, we should have seen evidence: radio signals, Dyson spheres, interstellar probes. But we haven't. The universe is silent. And that silence might not be random. It might be the result of a universal law, a deadly roadblock that all advanced life eventually crashes into. That roadblock is called the Great Filter. The Great Filter is a concept that asks, what if there's something extremely difficult, or even impossible, about progressing from one stage of life to the next? Imagine a series of gates. Each gate represents a major leap. Abiogenesis, the jump from non-life to life. Complex multicellular organisms. Intelligence. Toolmaking. Civilization. Space exploration. Galactic colonization. If even one of these gates is nearly impossible to pass, then most civilizations would die before ever reaching the stars. The Great Filter is that gate, and here's the problem. We don't know where that gate is. There are only two possibilities. 1. The Great Filter is behind us. Maybe life is incredibly rare. Maybe the emergence of complex cells, the leap from prokaryotes to eukaryotes, was a 1 in a billion chance. Maybe Earth is the miracle, the only planet to cross the hardest threshold. If true, we are alone, but also safe. The silence of the stars isn't a warning. It's confirmation that we are special. But what if the filter is ahead of us? This would mean that civilizations like ours do arise. But then they all perish. Nuclear annihilation. Artificial general intelligence that turns against its creators. Environmental collapse. Pandemics. Resource wars. In this scenario, we're not special. We're on a ticking clock. And we might be heading straight toward the barrier that wipes everyone out. What would evidence of the Great Filter look like? The answer: absence. Silence is the loudest clue. We've scanned thousands of stars. We've listened for signals for decades. Every time we look for advanced civilizations, we find nothing. No alien megastructures, no star-spanning empires, no von Neumann probes. The universe seems pristine, untouched. This could mean civilizations rarely reach the stars. Or it could mean they're all gone. You might think discovering alien life would be humanity's greatest moment. But in the context of the Great Filter, it could be our greatest fear. Because if we discover advanced life elsewhere, civilizations more evolved than us, it likely means the filter hasn't stopped them, which suggests the filter hasn't stopped us yet either. And if it's still ahead, then it's a wall we've yet to crash into. Every alien we find might not be a sign of hope, but a cosmic omen. They survived this far. Can we? So where is everybody? Maybe they're dead. Maybe they never got far, or maybe they saw the filter and couldn't stop it. We may be the first to cross it, or the last to try. The fate of intelligent life in the universe could rest in how we navigate the next few centuries. If we manage to survive, then maybe, just maybe, our voice will be the first one the universe hears. Or the last.